Hey everybody, welcome to another video. This one is gonna be a little bit different. Well, each video is different because I'm doing everything at random, but today I would like to say that, well, we surpassed 100 subscribers, which is quite a lot of people interested in this video, so that gives me a lot of push to continue, so this is it. So this is kind of what I promised a few videos behind, and it's an introduction into HAL. So this is the HAL driver, or the hardware abstraction layer from ST for the ST line of processors, and its idea is to be a little bit more in the upper levels and not as low level as the standard peripheral library. And this gives you much more power when doing complex things like USB, I2S, and other communication protocols, and I2C, which are not that easy to deal with manually. So the HAL can do a lot of things for you. Also, with HAL you can use the CubeMX, which is the software that the ST has been pushing for some time now, and the software allows you to initialize all the peripherals, pin, everything, and when you generate the code, it generates it like this when I have opened it in front of me. And the idea is that you don't need to care or put so much effort into the initialization. You just have to click what you need and it's initialized, and then you can go on with your project and what the project has to do. And so we had a lot more attention to the initialization in the previous videos, and that is fine because that gives you an idea to how things work. And now we're gonna also go into the pre-initialized code when we're gonna work in HAL, so we're gonna still understand what's going on. We're gonna read the datasheet and reference manual, because I think a lot of people just use HAL because it's available and it's easy to use and it's easy to start at such a steep learning curve that is ARM processor when coming from Arduino. But I still think you need to understand what's going on behind, because if there's a problem, you don't know what settings you have to change or anything like that. So this is kind of introduction to HAL, and what I have opened here is CubeIde. It's from STM. Yes, so I decided to use this because it has CubeMX implemented inside already, but I can also add other peripherals that I need or want for my own work. So it makes my work easier at my job or for just home project. And this is the latest Cube IDE, which can be accessible on this webpage. On the STM, you just search for this term. And here's a small description and all the downloads. And thank you, Linux installer, Mac OS, Debian, RPM, and Windows installer as well. So it's all here, and that's because it's based on Eclipse. So this is similar to the System Workbench, which is that free community-driven project endorsed by ST as well. But this is coming from the ST. All the latest processors are going to be supported in the CubeMX, so why make the jump? Because that's the main thing, because with the standard peripheral library you could get left behind. So just not to talk into empty, I have my project that I'm working on, and I think I'm gonna make a few videos about it because I think it's very interesting and we can apply knowledge from previous videos that I talk about the different peripherals and apply it to something that is a bit different, so something is practical you can see. And I have brought my oscilloscope from my workshop up, because when you're debugging something that's converting to analog or something to do with the real world, having just coding is not enough. You have to see on the oscilloscope how it's working. The debugger just doesn't cut it. So we're gonna switch to camera as well in the at the end, so I can show you a few samples. But for now, this is what I have. It's an I2S test, and not to be confused with I2C. This has nothing to do with this. I just forgot, but I2S stands for data for audio. It's a standard for audio transmission, digital audio, and it has nothing to do with I2C. It's just purely coincidental. And I'm doing this because I want to try some DACs, which are the digital to analog converters. We dealt with analog to digital converters from ST before, but now we're gonna use the ICs that particularly do this for audio. So I have a 24-bit DSC over here, which is a very good one from Texas Instruments, is the PCM1792, which is the programmable one, which can use I2C or SPI lines for programming for certain settings, and it has the fully differential current outputs, so you have to build a small board, which I have in front of me. And this is going to be a topic for our next video, how the electronics work, a little bit of theory about op-amps, and I think it's going to be a sweet transition into a more electronics plus embedded, because that's what embedded engineers do. You have to combine the code and the hardware, so get everything working. And in the end, maybe I have some music playing, and I'm going to talk about some shortcuts and some things that I decided to do and not to do. So let's begin and continue with our HAL introduction. This is going to be a long one, so if you're new to this video, sorry, but this is how I roll. I do certain things, talk about other things, but mostly everything is surrounding the same topic. So I have opened the STM32CubeIde, but it doesn't look like how yours looks. And that's because, well, I really hate light themes. Everything that's light like this just burns my eyes. That's why I have the redshift turned on all the time on my computer, and it's something that you get used to. But if I can, I have applied the dark theme. You'll also notice that my Linux is all dark, and I like it that way. And this is due to a theme. If you've known Eclipse before, you know that it has a marketplace. And let me open it. It usually takes some time, but let's open it right now. And on this marketplace, there is an add-on, you could call it, called the dark theme. And let me go into installed. And this is the darkest dark theme with dev style. And I also have applied the icons. So these icons are all different than what you have at stock. And also I have the new MCU Eclipse plugin, which I only use for the J-Link. And so I can support the J-Link debuggers. And that is all. This is all the Eclipse marketplace. Other add-ons are handled by the additional software, which is here. And this is the software from ST. This is stock Eclipse. This is just stock Eclipse with, here it is, the ST Cube add-ons. So you could theoretically take this HTTP, go into your Eclipse, plug it in, and download all the ST peripherals, and your Eclipse will turn into the STM32 IDE. But this is how this works. This is the package. You see the icons are modified and everything is made for this, but it's basically just Eclipse. Then another thing, at multiple jobs that I had, we worked with different tab size, and default is 4, and it's quite large. So if you search for tab, you have multiple options, and the first is text editor. I changed this to 2, and also click this insert spaces for tabs. Default is not applied, so you apply it, and this means that when you click tab, it actually inserts 2 spaces, which is beneficial because when you're removing backspacing, you're not doing it very fast because you would be deleting tabs, but you're deleting backspaces, so you have controlled deletion, so you don't accidentally, when you hold it, delete a whole row. Also, you need to go into C editor and go to the code style preferences, and in here it will still be 4. When you go to the edit for my theme, this will be at 4. So you change this to 2, rename it. I was lazy and just clicked fast and typed something, and you save it, you apply it, and you have now tab size 2, which is something like this. And tab size 4 would be this, which is quite large. So the code, in my opinion, looks a little better when it's tab size 2. This is tab size 4, okay? I copied this project, parts of this project from a website which uses 4. So in this case, this is a little bit better. It's more together, things that belong together. When you do an enter, it will automatically do 4. When you see, it will go very far when you have on 4. So I have a little project open here, and before I show you around the project, let me show you how to get to this project. So we talked about, you install it, you're probably smart enough to do that, and you can install this theme, it's very nice. Also, I have my own syntax highlighting. When we go back to preferences and let's go to dev style, and dev style preferences. Here is the workbench theme, so this is the theme. I use the darkest dark. I tried all of them and this is the best one. Primary colors, yeah, I use this one. And then the editor theme. None of this syntax highlighting really I didn't really like, but I used to use JetBrains a lot and I know it, and I download it from here. When you go to browse, you go to community made syntax highlighting. So I picked the one that included the JetBrains, and this is the one, Darkula JetBrains, and you just download it. It's an XML, and you just import it, and voila, click apply and close. So this is my syntax highlighting. All the windows, here's the editor window, project explorer, outline, problems, console, all of this you can bring from window, window, shot view, and other, and you have a whole list of all of them by categories, or you can just search for, I don't know, expressions, live expressions and all that, and you can, and it will pop somewhere and you can grab it and you just put it somewhere else. And I usually have console on the right, problems on the left when I'm compiling, so I can see the problems. And I try to leave only one row by the side of the editor, because I'd like to have as much as wide real estate instead of horizontal real estate, because I like to put multiple windows. Like I have the main file, I have C files, and I have .h files and so on, and so I can copy between them when I'm making functions and stuff like that. Outline, I don't really use it that much because I just know where everything is around the code, but if you have a larger code, this can definitely get in hand because you have all the definitions, includes, defines, and functions, and all of that. But I don't use other perspective because Eclipse has perspective, so this is just, you have multiple configurations how your windows look. In this case I have the MX perspective, which is the one that is responsible for doing the MX initialization of peripherals, so this is very plain, and usually it automatically opens when I open the MX editor, but mostly I use the coding one. And when I debug, I do not switch to debug perspective because I don't wanna the program switching between different perspectives. I manually click debug, which actually on its own opens up. I still use the console, and I just switch to variables. So debug switches automatically, and variables, so I can watch the variables. And I don't use anything else. If I do, I just manually go to window, shot view, and stuff like that. I also use build analyzer, which depending on your processor will calculate how much space you have and how much you're using with your code. So RAM, flash, so if you're doing lots of variables, you can see how much space you have left. And on this processor, which is the STM32F407, it has pretty good amount of flash, which is a lot, 1 meg, and 128 kilobytes of RAM, and it also has CCM RAM. So how can we create a project? So let's create one. Let's go new, STM32 project. We click it, and it's starting the initializer. It's gonna download everything it needs. So let's leave it to that. It's random, probably doing updates and stuff like that, but no problem, we have internet. Okay. And when initialize, we're gonna set our parameters of project, and it's on the left window. Let's scroll it back to here. Let's maximize it. So this is similar to CubeMX, but it's implemented in the STM32 IDE. So let's, for my board, search for STM32F4 discovery. Here it is. You click on it, you have all the sort details, large pictures, documentation, datasheet, everything. Yeah, this is the one we want. We click next. Then we give it a name. Let's call it a test. I'm gonna delete this afterwards, and it's in your workspace. You have multiple workspaces where each workspace has different settings for the IDE, so be careful when creating more. So I only use one because I really don't want to mess with these settings. I only have another one for work, so it has all the work projects open up. But that's it. We click next. You can leave all this default. Yes, copy the SSL library files and call finish. Initialize peripherals with the default mode. So this is gonna initialize the peripherals that are present on the board, because the software now knows which board we have and what the peripherals are on board. But let's create no if you want to make your own. Yes, want to switch the CubeMX perspective, so it's gonna do this empty one, and in the largest window is gonna open the configurator. So now we're gonna go into the configurator, which is very similar, actually it's the same one as the CubeMX. Here we have the processor and all the, let's do it like this. This is much better. So you have the IC that is on board, it's an LQFP 100 package, and all the pins. All the pins are set and are named because this leaves it like that, but they're not initialized in anything. You can go to pinout and clear pinouts, so it's all empty. Now, in order to start, what I always said, go for the clock. So the first one is the clock. It's in the system core, go to the RCC, and in this case it has ceramic, or it's maybe it's a crystal, so it has clock. So it has clocked going in, so this is gonna enable us to manipulate the clock. Next, yes, it has debug, it's a serial wire debug, here it is, and I know this, but you should check it in your datasheet. Here there's the SWO, this is the serial wire, single wire output, so this is the debug one we're gonna use. So this is the one we're gonna use, and this is it for this section. And in our case, when initializing any peripherals, let's say ADC, we click on 1, ADC A0 is in this case ADC 1, and we have all the ADC settings. Let's give some space. This is the clock for the ADC, resolution, alignment, scan conversion mode, continue. This is very familiar to you if you watch my previous videos. I've done this before manually. In previous we did a ADC manually by having a structure. We defined all these parameters that are in front of us, but in this case it's just a clicky click. Here the flag. If you have multiple channels, you can also click on the pin, and well, it's ADC 1 in 1. Wait, and it's configured. And you have multiple pins. You can go, okay, number conversions, we have 2 for 2 pins, and then we have multiple ranks. The first pin should be channel 0 and the sampling time, and the second will be channel 1. We can scan conversion mode is automatically enabled because we have multiple pins, so the ADC will scan through all the input pins, and if we go to continuous, it's gonna convert all the time. So this is just the settings we had before. No worries. So clock is inside, we have ADC, we have analog out, let's go GPIO output. It's gonna set it as output, nothing special. We can go to A to Z, let's go to GPIO, PD15 in our case. Here are some settings for the GPIO, the output level. This is the initial output level, so if your project has to be initialized at a certain point, you have to choose this low. So if you shouldn't have it on high because it could fry something before it initializes, then you can set it up here. Push pull, open drain, the pull up pull down resistor, output speed, it's not in megahertz, but it's kinda like that, like 1, 5, 20, 50 or 100 or something like that. And you can create your own label. You can go pin, and it's gonna be named pin, but we'll see how it will rename it later. We have timers to our spare, connectivity, all the communication protocols, multimedia, I2S in our case will be, security, computing, middleware, USB host, USB device, and FreeRTOS, everything you want. You can search this, do whatever. You have multiple CubeMX tutorials. This is just a quick pan if you're really first one. Here's the clock synthesizer that it's not initialized. We know that this processor cannot at 168 MHz, so let's create that. First we're gonna use the external crystal that is provided, and then increase this value of the PLL to 136, I think, and toof, yes, and this enables the 168 MHz clock. Is going for the PLL, and this is all as it should be. It's APB1 is, it's 42 MHz, well, okay, 42 MHz, and the APB1 timer clock is gonna be the double of that, and the APB2 is the same speed and the double again. But usually the APB APBs can be faster, so you can do it like this. Usually the APB2 is faster, or vice versa, no problem. So this is the clock, the project manager. This is the one that I want to talk more. I usually use the advanced because it puts the peripheral initialization in separate .c and .h files accordingly, and not all in the main, because I didn't like the HAL at the first and the CubeMX environment that just put all the initialization for all I/O and everything into the main, and in the main was already 300 lines long and just initialization alone. So I put advanced so that it creates a .c and .h pair files for all the initialization. So in this case, we can go to system view to see what we have initialized. ADC, GPIO, RCC is still in the main, but DMA, NVIC, ADC, GPIO, DAC, timer, everything is gonna put in ADC.c and ADC.h. Timer1.c, timer1.h. So it's much neater that you have all the initialization in other files, so you don't care about them. So that's why I use the advanced here. Well, we want the main. This is all good. Also, I generate peripheral initialization. This is this one. I made a little mistake. Yeah, this doesn't do that, but I think it creates a better structure. It put main in its own folders, like core. We're gonna look at them right now. And this option creates a pair c.h per peripheral. So this is the one that I was talking about right now. And this one just creates more folders, so it's a little more structured, so it's not all cores. And then you just, here's some tools if you want to, and that's it. Also, for some peripherals, like the simple one, GPIO, RCC, SPI, maybe timers, can be used by low-level drivers, which are the LL. So this will have LL before the functions. And this is if you want to use the low level, which is like a standard peripheral library equivalent. But if you really want the high speed. But that's it. We can just save it, yes, and it will generate the code for us. So this will generate this project, do all the .h files, all the folders, it's gonna initialize everything. So it is done. We can go back to our C, and this is the test. So it's gonna initialize it like that, and I'm gonna close this. Nope. I want to close this project. Nothing to clean. I'm gonna use this project that I'm working on right now because it's actually working on something. So it will create something like this structure. It will create a separate core. This is for the project specific. It's gonna create a drivers, startup, debug, and the source for the others. And all these files are just dumped here. This is for the IDE. And this is the IOC file. This is the one you open up to open up the MX editor. But here in the core, we have the includes and source. So if you have your own .c.h files, you could put them in here. So this will be compiled together, and then just include them in here in the main. If you're new to MX, well, this is not a tutorial for MX, but when it generates the project, it's very long and it has lots of comments and all of that. That's for good reason. You can reopen the editor and configure some pins differently and configure the settings for the peripherals something else, and it can create main all over again. But in order to not overwrite your code, which is what most of you would think and what normal person would think, yeah, how does it know what to change and what to delete and what to keep? Well, it uses these comments: private macros, private variables, private system function prototype, user code. So this private user code, all of that, this is where you write your code when it starts, begin and end. This is where you can write anything you want, and this won't be deleted upon new configuration. But if I type something like here, this will be deleted. Let's say I'm gonna, oops, let's leave it like that. I'm gonna save it, and I'm gonna go into the configurator. Yes, I wanna go into this perspective. So right now I'm gonna just change something in order to just recompile everything. So let's go in here and let's say this pin, UBADC in. I don't care about the settings, I'm just gonna save and generate the code. So in theory, that should remove that part where I have created. So it's working on it right now. It's indexing. And it's probably okay. So it was somewhere in here, and it's not here anymore because it has refreshed to the latest version that was been overwritten. But as you can see, all of my includes, this definition of pi and tau, and my code is still here because it was between the user code begin and end. Everything that had user code and begin here. This won't be deleted, but this will be deleted. So if you're new to this, watch out. But this is for the better. Although code is very long and it has nothing in it basically, it's still very good. This includes, these are from the system. This is the MX. The MX put this here. This is ours. So this will stay here. Not here. Here it won't stay. Okay, so this is the structure. This is how it gets overwritten. We can compile it, Control B, and it will recompile because we have saved a new version of configuration. Great, no errors. And we can see our flash and RAM. And this is the static stack analyzer that I usually don't use, but I have still opened it here. Outline and variables. Now the next thing is debugging. Here's the debug. And we can go to debug configuration. In my case, I use the JLink debugger. So I have the Sega JLink debugging over here, and I click on it. Here's the project that it uses, the ELF file, which is the one that it uses for debugging. The settings are stock. I have a global path to which is on my root. This is the debugger server. So this is the one that's gonna be opened. You have to name the correct name for the processor that you have. If this field is empty, then fill it out. And I have just put the absolute path to my GDB server because it didn't find it initially. I have the correct frequency for the SWO, so I can use the single wire output debugging, and all is pretty much stock. So this is debug, and when you click debug, it's gonna recompile, save all, recompile, and start the GDB server. Poof, and it started. As you can see that it opened debug. In this case, it would ask you if you want to transition to the debug perspective as it did before for the MX perspective, but I just clicked no and never ask again. And now we started in the main. This is the default breakpoint, and we can just F6, multiple lines, and just initialize codes one after another. We go here and we're gonna come to here, Control R, it's gonna run the code to here, and F6, and I can see some waveforms on my oscilloscope and stuff like that, and we can run it all over again. Great. And in this case, it's just creating a sine wave at a certain height. This one is really small. Let's create larger one, and you can add this button in the window. Perspective, customize perspective. So this is customize what you can see in your perspective, this is called. And you have to enable one of these debugs, it's gray. So you won't have all the settings, but if you enable all of them, you can have this one, which is very handy, which is the terminate and launch. And this is, yeah, it sometimes does that. It's buggy a little bit, but no worries. Another time it works. So this just compiles again and starts all over again. And F8. And it starts the code, and I see my signal being larger on the screen. I don't know if it's 16-bit or something like that. This is just for demonstration. But I don't know what else to tell you. This is the stock Eclipse, so if you worked with Eclipse before, you're gonna be right at home at here. All the configurations are other, and HAL is, well, it's a little bit different than standard peripheral. I'm gonna do the next video on it probably. This was gonna be just introduction into the whole environment and the project that we're gonna look into, and what all these functions do, and what I'm actually seeing here on my oscilloscope screen. So yeah, half an hour, so it won't make this video boring. The next one is gonna be HAL versus standard peripheral, just to compare and see all the files over here. So until next time, have fun and explore.